Hey everybody, it's Mr. MathWell here. I'm just going to go over some homework questions from 1.3 Calculus 30. We're talking about one-sided limits here. So here's number one. Here's the graph for number one. And let me just take a look at A here with you. So this says the limit of f of x as x approaches -2 from the right side. So that little plus sign says from the right side. So here's -2 from the right side. If the x gets closer and closer from over here, then the y values get closer and closer to 0. So that's 0. -2 from the right. Okay, what about 0? This is x approaching 0 from the left. So 0 from the left, well, that follows this graph up here. And so those values get close to this, which is 2. C says, what's the limit of the function as x approaches 0 from the right? Well, from the right, we're coming in this way. So from the right, the y values are coming to 1. Okay, what about the limit of the function as x approaches 0 without one-handed limits, just the regular limit here? Well, remember, the left-hand limit and the right-hand limit must agree in order for a limit to exist. So this one from the left was 2, and from the right was just 1. So this one does not exist, because the left-hand limit is 2 and the right-hand limit is 1. They do not agree, so it does not exist. Okay, so 2 from the left, that's going to be these values right here approaching y equals 3. And, or just 3, for y equals there is 3. 2, positive 2 from the right. Well, from the right, they're coming down here and also approaching 3. Now, it doesn't matter that f of 2 is only 2. This doesn't matter at all. We're not looking at this at all. We're looking at where is the function approaching, right? So the limit on both sides is the same. And what about the limit of f of x as x approaches 2? Well, because the left-hand limit and the right-hand limit are the same, then this is also 3. And finally, 4 from the left. Yes, there exists values of the function as x approaches 4 from the left. So the limit here is 4. Now, the function's not defined over here, so if this was 4 approaching 4 from the right, we'd have a big problem, right? There is no such thing. So, all right, that's number 1. I'll skip to number 3 here. So the graph of f is given. State whether f is continuous or discontinuous. Okay, so here's your two options. And of course, continuous means that it continues on where there's no jump or gap. So at -2 is right here. Okay, this continues on with no jump or gap, so it is continuous at -2. At 0, though, if you take a look from left to right, let's say, just for an example, as you come up to 0, well, it pops down, the evaluation is here, and then as it continues on, it goes down from here. So that's a jump discontinuity. So that's discontinuous. At x equals 2 for C, well, because we have this hole or gap, that is also a discontinuity. So this is a gap discontinuity. This is a jump discontinuity. You don't have to say, which one is which, but that's a gap. This is a jump. And x equals 4, well, that's continuous. There's no hole, there's no jump, there's no space there. So that's continuous. And then, of course, at x equals 6, because the function is clipping along here, just real nice. And then, boom, there's a big space there, and it jumps down to here. So that's a jump discontinuity. Okay. Number 4, find the following limits if they exist. Okay, there's a couple ways you could approach this. One way would be, just to say, let's plug in the value and see what we get. The problem with that is that if the x value that it's approaching, if it's a problem, so for example, for number C here, letter C, x equals 1. Okay, well, 1 minus 1 is 0. Square root of 0 is fine. But if we had something greater than 1 over here, 1 minus 2, let's say, that's not fine, because square root of a negative number is not fine. So you have to know a little bit about the function, or a little bit about the behavior of the math of the function. So what I'm saying is this, is that if you plugged 1 in here, you would get 1 minus 1 is 0. So the limit you would say would be 0. But that actually only holds true as x approaches 1 from the left, because from the right, as we said, if it's bigger than 1, then this is negative, and then it does not exist, okay, if it's 1 from the right. So you do have to consider that. I would suggest, if you're unsure, well, first of all, you could graph it and then take a look at the graph. But you're not always going to get the chance to graph it to do these questions, so you shouldn't know how to do this without graphing it. If you chose, because this is 1 from the left, if you chose a number like 0.999 instead of x, and you did this, and you evaluated this, that's going to get you pretty close to your limit. If it was from the right, and you chose, 1.001, well then, square root of a negative number would be an error, so then you would know that it does not exist. So this is always okay too. Let's pop over to f here. So 6, well, so 6 minus 6 is 0, absolute value of 0 is just 0. Well, if you know a little bit about this graph, this is, it's an absolute value graph that looks kind of like a V, and this has been moved to the right 6 units. So it kind of looks like this, right, where this is 6 here. So as x approaches 6 from the left, from the graph, you can kind of see, hey, it's coming down to 0 here. From the right, the same thing. It's coming down to 0 there. And again, if you put in, instead of x, I should say, 5.999, because that's something that's just to the left of 6. And you plug that in, you would have 5.9999. Minus 6 is negative 0.001. Absolute value is, it's just under 0. Sorry, negative 0.001, just under 0. And that's going to be really close to 0. Okay, so that's another way you could do that by the graph, take a look at it, and knowing a little bit of the nature. This one is a weird graph, h, if we look at h. So think about this, 0 from the right, so that's going to be positive value for x, that's going to be positive. And this absolute value of x is the same number, and absolute value makes it positive. So you basically have positive x over positive x. So that's going to be 1. Here, I, okay, is, what's the limit of this as x approaches 0 from the left? Well, from the left means that this is going to be a negative value down here, right? Because it's a little less than 0, it's negative. But this will also be negative in here, but because of the absolute value, it makes it positive. So whatever x is, okay, if it's negative, well, it's going to be positive value on top divided by a negative value on the bottom, and that's going to be negative. And that's a weird graph, right? So that graph actually looks kind of like this. It looks like this. So it's going to be positive 1 when x is greater than 1 over here, right? X is greater than 1 over here. And it's going to be negative 1 whenever x is less than. So it's going to look like this. All right, being that these are the graph. This is the graph right here. There and there. Okay. How we doing? Hopefully you guys are doing okay. Number 5. So we got a piecewise function here. If we sketch this real quick, y equals negative 1 for anything less than 0. So negative 1 less than 0. Open circle because it's not or equal to. So it's a horizontal line at x equals, or y equals negative 1. Right? Y equals x plus 1 for anything that's at 0 or greater. So x plus 1. Now that's a line with a slope of 1 that goes through positive 1 as an intercept. So here's positive 1 up here. Positive 1 here. And it's got a slope of 1. So that's what this looks like. All right. So the following questions now will pertain to this graph. So if you do the graph, that's easy to sketch. I suggest you do that. But I'll show you how to do that without the graph as well. So x approaches 0 from the left. Well, the limit's going to be negative 1. X approaches 0 from the right, positive 1. X approaches 0, just a two-sided limit doesn't exist because the left-hand limit and the right-hand limit do not agree. Now, let's say we did not have this graph. Okay, we didn't have this graph. And you know that this is a straight line, horizontal. This is also a straight line. There's no restrictions per se in these, like x can be 0 or negative anything or what, positive, decimal, whatever. There's no restrictions. So mathematically, we don't have a problem with any number here. So if you wanted to find out, hey, from the left, what is this limit going to be? Well, to the left of 0 would be this one. That's to the left of 0, right? So that means it would look like this. So there's your limit. To the right of 0, so x approaches 0 from the right side, to the right of 0 is this one down here. So then you could plug 0 into this to find out what the value is, right? Or when I say plug 0, you know, really what you're doing is plugging something that's infinitely close to 0, but on the right-hand side of it. So it's like 0 plus 1 would behave like this. 0 plus 1 is 1. That's why I get the limit of 1. Okay? So you can simply plug values in, assuming that, you know, even if I do that again, assuming that this would continue on, and assuming that this right here would continue on, right? They are continuous functions in their own right. So you can just plug values in. You just got to know which one to work with when you're on this side of the 0 and this side of 0. Hopefully that makes sense. I laugh. I mean, it's not funny if you don't get it, but I'm like, I have no idea if you understand it or not. Awesome. Okay, come to my class. Come talk to me. All right, so I don't know if we should do number 6, but let's give it a go. Without graphing it, so we're talking about x approaching 1 from the left, so which one is that? Is that this or is that this? Well, this is the less than, right? So it's going to behave like this. So what if I plugged just a regular old 1 into there? Well, 1 squared is 1. Okay. This one is approaching 1 from the right. So that's where we have x greater than 1. So that means I should plug 1 into here to find out sort of what this limit might be. And again, we have no restrictions, right? Nothing mathematically wrong with plugging 1 into either of these. No big deal. So 2 minus 1 is 1. Does the limit exist in general? Yeah, sure does. Left hand and right hand are the same. So if we were to graph that, all right, I'm putting this into Desmos. I thought I'd show you how to do this. It's actually pretty cool. You can do piecewise functions in Desmos. So if you look over here on the right of the screen, oops, see, I've got this. Oh, come on. I've got this in there right now. And how you do that is you have to go, oh shoot, you know what? You guys can't see that. Sorry. I see that I have to move things over. Because you can't see the very far left of the screen. Okay, I think you can see that now, right? All right, so we have y equals, and then these funny bracket, the braces there. So x less than or equal to 1 colon x squared. Make that a little bit bigger for you. There we go. So that's the first one. So I'm going to do the next one. You got to start with this part right here, hey, x greater than 1. So I'm going to go y equals braces x. Now down here you got your operators, greater than, not or equal to, but greater than 1, colon, no spaces or anything, and now just 2 minus x. And there you go. You see how it pops up there? Oops. So here we go, right there. So if I just make that a little bit bigger, and there you are, so we can kind of see, right? We can see that this is continuous at x equals 1. A limit does exist. It's y equals 1. And we're good to go. So intercept, there's the intercept. Okay. So what does the question ask here for these ones? Yeah. What happens coming up to 1, right? So zoom in, there's 1. So as x approaches 1 from the left, right? I don't know if you guys can see that there. As x approaches 1 from the left, y, so look at the y values there, starts to approach 0.7, 0.8, 0.9, 0.9798, boom, 1. And as x approaches from the right, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, boom, 1. Now, it's undefined there at that exact point, because look at the blue graph. See, it doesn't include 1 over here, see? Not or equal to, see? So, yeah, follow the blue graph, boom, undefined. Follow the red graph, boom, it actually lands in there, 1, 1. Cool. Cool. That is cool. Sorry. I'm embarrassing someone right now. Namely my children. Sorry. All right. So, I don't know. Do I need to do 7? Let's see. I don't know. 5. What's going on there? 9. Niner. Okay, maybe let's take a look at 9. 9's got 3 sections, no problem. Could you put this on Desmos? Yep. Do you need to? Not really. I feel like I did this one. Maybe I did this one in class today. All right, well, here you go. You guys haven't seen it probably. So we got 3 sections. Where are we? Less than -1, so I'm gonna put -1 over here. Between -1 and +1, so that's this middle section, and then greater than 1. Awesome. So what happens less than -1? Well, we've got some parabola here, don't we? This is like a parabola. That's x squared, but it's been moved to the left. You see that? So where it would normally be something like this, it's moved 1 unit to the left. So guess what? We have this going on where -1 is our vertex. And I'm getting a call. That's embarrassing. All right, here we go. I'm back. It's my wife. It's her fault. So here's x squared. Let's change colors. Go red. So between -1 and 1, we've got x. Y equals x. So remember, that is a graph that looks like this. And then starting at -1 would go here, solid line, up to +1, right? So that's 1. And that's -1. So that's this red one, that's between. Now, because, see, I put in both solid dots because the or equal to here on both sides. See that? That's why solid dots. Now, technically, I should have done this a little carefully, but see, that's an open circle there, see? Because x equals -1 is not included there, but that little open circle says that it goes right up to that point, infinitely close, but doesn't touch it. So the little open circle is actually important there. And then over here, 2x minus x squared, because this is a parabola because of the x squared, it's negative coefficient on that x squared, so it's opening down. If you don't know exactly where that kind of goes, you could just do a quick table of values. So like at x equals 1, what happens at x equals 1 there? Well, that's 2 times 1 minus 1 squared. That's 2 minus 1 is 1. So actually, it would start here, and then it opens down with a normal width. So over 1 unit, down 1 unit. So it would hit the axis here. So it looks kind of like that, see? So that's what this piecewise function looks like. So once you got that graphed, you could totally just check out, you know, the limits and stuff. So over here on the right, make that a bit bigger for you. Over here on the right, it says, what's the limit of f of x as x approaches -1? That's on over here from the left. Well, that's these y values. What's it going to? 0. What about from -1 from the right? Well, that's these y values. It's going down to -1. Hopefully this is getting easy for you. Is there a limit at -1? Because there's no plus or minus up there, so it's just a two-sided limit. Is there a limit? Nope, because these are different. So D and E does not exist. What about +1? Yep, from the left, it's 1. From the right, it's 1. Does it have a limit? You bet, it's 1. Boom. So again, to check that, if you didn't have the graph, right? Let's say you don't have this at all. Gone? You don't need it? No, you don't need it. What you do is you say, okay, so 1, obviously, -1 and +1 are our 2 points. The 2 x values where things might change, right? So with this one here, -1 from the left, that's before this, so it obeys this one. So -1 from the left, you put -1 in here and see what happens. -1 plus 1 squared, that's 0. See that? This one over here, -1 from the right. Okay, well, what's to the right of -1? That's this part right here. And so then you plug -1 into x. So -1 equals -1. That's where you get that one. And then here, both sides, well, you'd have to basically do both of these and compare these. So you'd have to plug -1 in here and -1 in here, like we just did, compare the two numbers. Likewise, 4, 5, and 6 here. So +1 from the left, okay, where's +1? Oh, this is on the left side of +1 right here. So there you go. That's 1 equals 1. And from the right side, just to the right of 1, that's this domain. So I plug 1 in there. 2 times 1 minus 1 squared. That's 1, 2. Right? Excuse me, talking too much today. Okay, sketch the graph. Okay, we did have to sketch it. Where is f discontinuous? Well, it's at x equals -1. Discontinuous at x equals -1, or just before and just after. Nice. What else do I have for you? Wow, 13. Okay, 13. Sketch the graph of f, determine any values of x at which f is discontinuous. So here I started, doing some values here for this 1 minus absolute value of x. And this might throw a curveball on things. So this is basically when when the absolute value of x is less than 1. So that's this between -1 and 1, okay? When the absolute value of x is less than 1, that means regardless of the sign, that the value is less than 1. So it's like a decimal, right? So in here, in between -1 and 1, it looks like this. 1 minus absolute value of x. So if it's 0.5, let's say, 1 minus -0.5 is just like 1 minus positive 0.5, so it's 0.5. If it's a positive 0.5 over here, 1 minus positive 0.5 is 0.5. So, and what about at 0? So at 0, 1 minus 0 is 0. Sorry, is 1. 1 minus 0 is 1. So, wow, this is looking pretty strange, isn't it? I'll just move that up. Oh, darn. This can come back down. So 1 minus 0.5, what am I doing? Yeah, that's it. This should be up here. Because this is 0.5, this is 1. Okay, so 1 minus, yeah. So it's like a, here's absolute value of x, right? Negative absolute value of x is flipped the other way. And then basically +1 moves this whole thing up 1 unit, or 1 minus this is the same thing. So this is looking like this and like this, right? Okay, it includes -1 and 1 too, okay, because it's or equal to. Okay. What's this one? Absolute value of x is between 1 and 2. So that's between 1 and +2 over here, and between -1 and -2. That's what that means. So the absolute value of x, just the number itself, is between 1 and 2, whether it's positive or negative. So this behaves like absolute value of x minus 1. So here's absolute value of x over here. Here's absolute value of x minus 1, where this is -1. So how do I draw this without including the -1 to +1, right? Okay, so that's going to look, let's do it in blue. This one's in blue. It's going to look something like this, right? Open circle. And then closed circle. No, sorry, up to 2 is closed circle. That's open circle as well. Up there, closed circle there. Okay, so this is less than 1, and then it goes to 2. All right, so greater than 2 looks like this, x minus 3 squared. So that's x squared, which is a parabola that has a vertex at 0. This minus 3 inside with the x means that it moves to the right 3 units. So that's going to go over here 3 units. This is going to be 3. So 3 up here in our graph is 3. That's going to be part of the parabola here, and it's going to go up like that, right? Now it's just a 1 there in front of the x, more or less. So it's a regular opening width. So that means from the vertex you go over 1, up 1, and that is 1. So it's going, you know that it's going to touch there. Open circle technically on the parabola. And then x plus 3 squared. So that's the parabola going the other way here. -3, right? And so that's where x is less than -2. So way over here. So at -3, boom, -3, and that's going to go up. This is going to go up like that forever, and like that forever. So that's what that one looks like, and you could sketch that one out and just double check that, but determine if it's discontinuous anywhere. Well, according to my sketch, it doesn't look like anywhere. Looks like the touch there, touch there, touch there, touch there, right? So we're looking at 1, a -1, and 2, and -2. Yeah, look at that. There's the answer key, and it looks just like what we drew, hey? Pretty cool. So it is continuous everywhere. Yeah, on all values of x. All right. Okay. There you go. We're going to take like a 1.4 next video. Poof, you made it. Good job.